not. Yeah, please assemble for the technical session 2. There are 3 speakers, and chairman is Dr. Ekera. He is the technical advisor of lecture, and he is also part of the editorial board of Steel Tech. So please assemble, and we'll have 3 presentations in this. And before that, maybe if Avinav is here, I can just call him.
Well, good afternoon. So in the post-lunch session, we are starting the technical session number 2. We have got 3 papers in this session, and we have about an hour or so. So I request all the speakers to restrict their presentation for 15 minutes, and then maybe for 5 minutes we have the interaction. Okay, I'll now invite our first speaker, Mr. Juha, who is from Autotech Metso in Finland, and he'll be talking on Metso Autotech ferroalloys and DRI smelting. I'd just like to introduce him. He's basically has done BSc in Mechanical Engineering and Automation and MSc Industrial Engineering and Management. He has got 15 years of experience in Autotech Metso in ferroalloys sales, before 10 years in ABP, in various engineering projects, managements, and sales positions. His current focus is supporting India to become the global leader in ferrochrome production while utilizing Metso technologies. Mr. Juha, please.
All right. Thank you for the introduction. Thank you, Mr. Pekosen, for giving this opportunity to present here today. And thank you, Steel Tech, also for having us. And then special thanks to my colleague, Dr. Timo Haimi, who was supporting me with the presentation. And let's see if the microphone is okay and this is coming not too loud for you. So anyway, good afternoon from my side. So coming from Metso. Actually coming from Finland as well, so the headquarters of Metso is located in Espoo, capital area of Finland. Working in sales, been Metso 15 years now, focusing on ferroalloys and smelting projects. And today's topic and target is to show how proven smelting technologies can be used to solve 2 challenges, let's say India and globally the industry is facing. So the challenges are how to produce cleaner ferrochrome, and the second topic today is the transition toward low CO2 iron making without blast furnaces. So Metso is not talking about concept. We are talking about proven smelting technologies that enable competitive and clean metals production. So I start briefly with Metso, then going into our smelting background, and then telling a story about China, what did they do in their ferrochrome industry. And finally I focus on DRI smelting, which we see as a key enabler for the green steel. Okay, my background came many times, so 15 years in Autotech, and then before that I was 10 years in ABB, in the electric machines business. Also India at the time was heavily part of my work. I actually spent at 2005 3 months in Vadodara when we built electric machine shop. And since then, let's say, I've been traveling in India 20 years, and past 5 years I've been fully focusing on the ferrochrome industry in India. So I forget to say, but it's good to meet you all, the community of ferroalloys and the stakeholders in ferroalloys business in India. So very nice to see you, very nice to meet you all in this event. So like said, one of my personal targets is actually support India in becoming a leading global ferrochrome producer using technologies which actually are proven elsewhere. So basically we don't need to invent anything new, we can just use the technologies which have been tested elsewhere. During the past years, I see a major changes in global ferrochrome market. China is dominating in ferrochrome like in all metal supply. South Africa and Europe are suffering. So India, having the own high-quality chromite available, I think it creates a great opportunity to India become a future leader in the ferrochrome industry. So, briefly about Metso in general. Metso is a 5 billion euro technology company with almost 20,000 employees. We are focused on mining, metals and aggregates. What matters for our customers is that we combine process technology, equipment, services and research and development into a one offering. And in my opinion, this is especially important for smelting, where the long-term stability, scaling up and performance over decades is critical. And how are we present in India? So we have offices in Gurugram, the head office, and we have 5 regional offices, Kolkata among others, and we have 20 service offices, and then 4 manufacturing sites, which are located in Alwar, Ahmedabad and Vadodara. And to mention, the Vadodara, okay, it's a familiar place to me from my previous career. And then next we will enter into Metso smelting solutions, and especially the ferroalloy solutions. So, the background of Metso smelting and Metso's way of doing. So we don't sell single machines, but we deliver complete process solutions. And when we talk about smelting, it never works in isolation. So we design the full value chain from the raw material preparation to smelting, and then take care of the off-gas handling and downstream refining. And this is actually how we ensure the energy efficiency, environmental compliance and high metal recovery. And smelting is not a side business for Metso, it's the core capability. So alongside copper, battery materials and recycling, ferroalloys and DRI is one of our key technologies, especially for customers targeting lower CO2 footprints. So in smelting, Metso is well known by the copper, the flash melting technology, and on the ferrochrome side, the Metso's or Outotec's ferrochrome process is widely applied in the industry, especially in the large-scale operations. So, to mention some of major ongoing projects in India, we are currently building e-scrap plant for Hindalco Industries, building ferrochrome plant with Vedanta, and one major copper smelting project also ongoing in India at smelting site. But of course there's a lot of other Metso businesses who are selling the concentrate equipment mills and such, so they are doing more daily business here. But these are the large-scale projects I should mention at this point. Yes, Metso covers both ferroalloys and iron and steel, and we work across various ferroalloys. So ferrochrome, ferromanganese, ferrosilicon, silicon metal, but also in iron and steel decarbonization at the moment. The same fundamentals apply throughout all our offering in the smelting. Technology is developed and tested in Metso, not theoretical. So we have 45 research and development centers and testing locations globally. In Finland, we just built and operate a pilot-scale smelting facility which was built basically to develop the DRI smelting process. So this allows us to reduce the project and scale-up risk before the customer commits to full-size plants. And now we move to the actual customer cases, and I'm telling to you a story about China. How did they transform themselves? Okay, sorry. Yeah, that was actually the correct one. Yeah. How did they change themselves during the past decades, and what was the impact and influence what the legislation change did to technology selection? So during the past 2 decades, China converted its ferrochrome industry to one of the most modern in the world. Metso's ferrochrome process played a major role in that transformation. And to mention that the Metso's ferrochrome process, it did not appear like after one night, but there's decades-long history behind that. So we have tested the pre-reduction with rotary kiln, we have tested briquetting, etc., and moved forward from those and developing something else. So how China operated before 2010? So they had the old smelters, high losses, high emissions. Historically, ferrochrome production relied on the open semi-closed submerged arc furnaces, and they had severe disadvantages like heat losses, uncontrolled combustion, chromium-6 formation, high emissions, and increasingly failing environmental regulations. So then China changed actually the legislation. They realized that this route was unsustainable environmentally and economically. So this created demand for closed, energy-efficient smelting processes. So basically everything started from the law change. And then the solution what the Chinese major suppliers selected was this Metso's Outotec ferrochrome process. So I don't have time to go to the details of the process at the moment, but basically it is based on production of sintered pellets with the steel belt sintering technology, and then smelted with the submerged arc furnace where the preheater is integrated, and the system is fueled basically from the off-gas coming from the furnace, and the extra CO-rich off-gas can be then used, like heard today, can be used as a cogeneration source or source of production of ethanol, methanol, or what is seen feasible. And the performance is proven by numbers. So this is the outcome what Mintal has publicly announced. So they have significant saving in coke consumption, power consumption, realizes like below 3,000 kilowatt hours per ton after utilizing the CO gas in the cogeneration plant, reducing dust emissions and reducing the sulfur emissions, and closed the old multi-furnace plants until 2014. And sorry, I need to speed up a little bit, but just to say that everything is actually done in China. So in my opinion, this can be also done in India, but a lot faster, because nothing new needs to be invented. We can just take the existing technology and utilize it here. And okay, maybe many of you know, but I'm happy to say that, let's say maybe this year, or I don't know when the plant will be commissioned, but you will have Metso's ferrochrome process installed also in India in large scale. So this will be one of the major ferrochrome production plants in the world after they are able to ramp it up. And all right, I think coming close to 15 minutes and I still have the another topic to go. So just to mention that, okay, we are also working in DRI smelting currently, and this is one of our, let's say, key targets at the moment to prove that this is a feasible route to produce green steel. So it is a DRI route and then combined with the electric smelting, but the smelter is large-scale submerged arc furnace able to deal with the Kangyu, so able to deal with the slag. And afterwards this is then producing clean hot metal with 99% iron yield. So the benefit of this kind of solution is that it accepts all DRI qualities, no need for blast furnace, no coke ovens, very low carbon footprint. Okay, all matters and comes down to the method for the pre-reduction, of course, but it should be hydrogen-based, so then there is not too much to reduce in the submerged arc furnace, and then you do not need too much coke for that. So that's how the carbon footprint becomes low. And this is, okay, finally, this is like the first public reference case. The Fortescue Minerals in Australia, they are currently building the green steel pilot plant in their site at Christmas Creek, and there will be Metso's pilot scale DRI smelting furnace and then the Circored pre-reduction. So the furnace will be commissioned during this year and the pre-reduction plant follows. So still quickly the conclusions. Metso has proven how smelting modernization transforms ferroalloys production. The same smelting principles are now enabling the transition to low CO2 iron making. And I'm ready and we are ready to work with the Indian customers from the concept studies to pilot tests and then the full-scale plants. So at this point I want to thank you and look forward having further discussions with everybody. Thanks.
Thank you, Mr. Juha, for this excellent presentation. We may take one or two questions from the audience. If you have any queries. I think you have some, no?
So Juha, you mentioned that for DRI you have a plant. So what is the feed metal? It's iron ore, is that what you're putting into this?
Yeah, so the feed material to the Metso's DRI plant, it is developed for the lower quality iron ore.
What quality? Can you specify? What kind
lower
of
quality? Well, I think it's, let's say, it's the blast furnace quality iron ore, which is not suitable or not ideal for the electric arc furnace route. So this Metso solution is developed for the lower quality materials which produce a more slag which the submerged arc furnace is capable of handling.
But are you supposed to carry out some kind of reconditioning, some beneficiation, or as it is you are putting into the furnace, is that?
Yeah, of course, meanwhile Metso is working with the beneficiation side as well to trying to improve the iron ore concentrate quality, yeah.
You gave an example of the furnace in Australia you have that's coming up. So what exactly is that in the material balance?
Raw material balance?
Yeah.
Yeah, well, this is actually not being published by the customer, and to be honest, I don't even know. But anyway, it's not public information. But the Fortescue Minerals, of course, they are not the smelting company and not the iron producer, but they are the mining company. And they want to demonstrate that it is feasible to produce the iron at the mine site and sell that iron to the downstream steel producers.
No, that's good. That's a value addition, but as long as it's commercially feasible, that has to be looked at.
Yeah, we will see during this year. They will run like maybe 1 year campaign with various feed materials to demonstrate that what's possible.
Okay, thanks.
Any other queries? Okay, if there's nothing, then we'll switch on to our next presentation. It will be presented by Mr. Diptendu Bhattacharya. He's CEO IISSC. He'll be talking on skilling of metals industry for the future. Mr. Bhattacharya is a mechanical engineer from IIT Kharagpur, followed by an MBA from IIM Ahmedabad. He has over 34 years of sales and marketing experience in different industries. The longest has been in Godrej and Weiss for 20 years. There he has seen the use of steel from the consumer side, both for consumer durable manufacture as well as for the manufacture of high-end capital goods for oil and gas, power, nuclear, logistics and defense industry. Currently, he is closely working with the steel and metals industry for skilling initiative as CEO of Skill Council for Materials Sector. Mr. Bhattacharya, please.
Thank you, sir. And thank you, Steel Tech, for having us here. I think this has been a very instructive day. We have had a lot of speakers to speak about the ferroalloy industry and the various technologies associated with it. I would like to start by talking a little bit about our organization. IISC is a skilling company, and it's a non-profit organization set up by the Bengal Chamber of Commerce and INSDAG. It's been also set up under the Ministry of Skill Development and NSDC, but it's a PPP partnership with industry, and the governing committee constitutes of senior officials from the large industries in the metal sector, primarily the steel industry as well as the non-ferrous metals. As we all know, the iron and steel sector has a large number of job roles and occupation maps, and today's discussion focuses on the ferroalloys industry, which we'll be talking about. One of the main tasks of our Skill Council is to create curriculum for job roles, various job roles in the metal sector. And this is just a glimpse of the over 100 job roles we've created, out of which 67 are active as on today. A study done by us a while back showed that the requirement of fresh skilled manpower up to 2030 would be about 19 lakhs. This would be in various roles as is seen in this picture. To focus on ferroalloys is the key to the steel industry. While the iron ore itself presents the basic raw material for the steel industry, ferroalloys are the essential additives that define the steel strength, corrosion resistance and other products. And I think as we have all heard in the past, in the morning today and afternoon, ferrochrome and silicomanganese are the largest, with manganese now becoming the largest ferroalloy in demand. And the Indian market size is about 5.5 billion as on today, which is projected to reach 10.8 billion by 2034. We have heard about the target set by the National Steel Policy from 300 million tons capacity by 2030. We are hearing today about 400 million tons by 2035, 2035 and about 500 million tons by 2047. That really sets the ask from the industry. The main hubs for the ferroalloy industry today are Odisha and Chhattisgarh for the chrome belt, Andhra and the northeast for manganese and ferrosilicon. And you have, of course, two major types of players. They are the integrated steel producers who produce the ferroalloys as well as use it for their own production, captive production, and then there are the merchant manufacturers. The challenges for the upstream industry is in mining, we need better beneficiation. There's been enough said about it so far. And in case of manganese ore, the ore is of low grade, which is why we need to mix it with higher grade ore from imports. One solution which we have already heard today about how you could try to improve the beneficiation in India for the low grade ore and thereby circumvent the requirement for imports. Energy is the primary input and it accounts for 40 to 70% of the production costs. Yes, to produce green ferroalloys, we need to look at renewable sources of energy. Metallurgical coke and low ash coal also remains a major component of upstream sector. We'll be focusing on ferroalloys, of course. Yes, the ask for greening, it encompasses the entire supply chain from the mining stage to the refining and production of ferroalloys to the actual manufacturing of steel and its downstream products. So if we talk about the ferroalloys per se, the low ore content leads to loss of energy in the blast furnace and need to clear up the impurities in the output. We have just heard about the problems that higher phosphorus levels and sulfur levels cause in the production process. The high carbon content in the ore also leads to greater greenhouse gas emissions, which can be eliminated through better beneficiation, refining of the ore. Decarbonization and CBAM is forcing us to look at using green ferroalloys in order to produce green steel. And the submerged arc furnace automation does reduce energy waste. Slag recovery is also being used in a larger quantity to produce value-added products. And we can recover some amount of ferrochrome and other ferroalloys also from slag. There's a major demand, rising demand for more and more specialty alloys in automotive and defense sectors, and we have been importing them hitherto in large numbers. So the data which was presented earlier by our speakers saying that we have a marginal net export of steel is largely because of the high import of high value alloy steels. If we can manufacture them in India, then we could reduce our import dependence and increase our exports of steel. So the mission of my organization, IISSC, is to bridge the skill gap that exists in the market. Smelting is energy intensive and hazardous, and experience-based operation is not enough for continuing our operations in a competitive world market. The entire process of steel making is hazardous, and safety training enables a safer working environment with fewer disruptions. That improves productivity, that improves worker confidence, it improves customer confidence. Future skill requirements would require training on Industry 4.0. The pre-lunch session we had the speaker talking about Industry 5.0. I think that's quite a way off for Indian industry. Today, many of our plants are at 2.0 and moving up to the 3.0 stage. So we would have to look at moving to 4.0 at first. We also need to train our professionals in carbon footprint accounting. Today, every source of rupee is valuable, and by accounting for carbon footprints, we could earn carbon credits through the initiatives we are taking, and that could help us to increase our EBITDA. And of course, training in thermal hazards and high voltage equipment is also important. With the increasing use of electric arc furnace and induction furnaces, which are cleaner technologies with much lower greenhouse gas emissions, we need to train people in high voltage equipment. So the goal is to move from unskilled to certified technicians to improve global competitiveness. I think all of us are aware that a vast section of our workers are totally untrained. They have entered as novices, many cases uneducated people who barely know how to sign their names, and they have learnt on the job. That doesn't make for a very trained and structured learning. It is seat of the pants learning, a lot of jugaad technology, as we are proud to say, which doesn't really deliver results in this highly competitive age. So we need to certify them for them to adopt disciplined processes of working, of safety, and observance of manufacturing protocols. So we believe that we had to facilitate the deployment of new technology in our plants. In the skilling in architecture, we have been focusing on the steel industry, while our sister skill council, there's a mining skill council, has been working with the mining industry. Maybe many of our organizations here in the ferroalloy industry may be familiar with them. And National Skill Development Corporation has asked us to form a cohort wherein we work hand in hand together to solve skilling challenges at the intersection of two industries. After all, the output from the mining industry, the ferrochrome industry, feeds into the steel industry. So they're not separate actually. They are simply two parts of the entire value chain. And where solutions are developed for the industries, the team has to work together to beat the challenge. This has been mentioned earlier, that partnership with academia can find solutions. Every country has its own peculiar situation. We have a low concentration of ores. We have a high geographical dispersion and high energy costs, low skilled labor. So we have our own challenges which have to be met in our own peculiar ways. And future production streams have to be designed seamlessly across the upstream and the steel making sectors to make this happen. So we would have to evolve from a low-end raw material exporter to a high-end specialty alloy producer. This would be true for ferroalloys as well as steels and other metals. And we need to develop our human capital to realize our demographic dividend. We have a huge workforce who are eager and thirsting to have a better quality of life, a better self-respect in society, and a better productivity, which could help the nation. So technology is only as good as the hands which operate it, and IISc is committed to creating a future-ready workforce. We are not just making alloys, we are strengthening the bones of India's infrastructure. Let's build it with precision and skill. Thank you.
Thank you, Mr. Bhattacharya, for a nice presentation. We may take a couple of questions from the audience. Yeah, please.
Are you asking? Should I go?
Yeah, first let him speak.
It was nice presentation. Yeah, I'm from the academic part of it. So first question is to you is that how do we connect with you? This is first question. And I have got 2-3 suggestions for you. If you have given a table where you have divided that the total steel industry, then ferroalloy, and then refractories and all those things. There I could not find the quality assurance of the total material. You know, the steel industry, quality is a very important part, as from the raw material till the end of the material. You know, the raw material, then sinter plant, coke ovens, blast furnace, everywhere you require some kind of quality of all the products, even if in the inputs and outputs. So I have a suggestion for that. I think I have submitted two of the trainings which we have submitted to, I think, your predecessor, Mr. Sushim Banerjee. So if you can look at it, one of the things. Another suggestion is that everybody is looking about decarbonization and sustainability of it. Could you put some kind of training session for all the people, because those who are working down the line and at the plant, they don't have any idea of the sustainability and decarbonization part of it. So it's now a part of our life. It has to be there in the next few generations. So if you can think of some kind of training on decarbonization for whole gamut of the people, that will be a good game changer for the people, for the industry. So these are the two suggestions I'd like to put it, and please help us how to connect with you, and so that we can develop some kind of new skill which can be given to the steel industry.
Thank you, sir. I believe as soon as I leave the dais, I would share my contact details with you, and we'll be very happy to connect with you offline. With regard to the quality assurance, I think as you mentioned yourself, it's an integral part of each and every process. So having a separate department for quality assurance wouldn't serve the purpose. Instead, it has to be embedded into each and every process. Yes, we may have some people who are primarily responsible for ensuring quality, but it has to be a part of every operator, every manager, every supervisor. And yes, with respect to skilling in the decarbonizing area, we'll be extremely happy, sir. Currently, we have a set of job roles created, and one or two of them address it, but we are happy to create even more job roles as per the industry requirement and skill people for it. We have a wide network of training providers, and we can train people in all parts of the country. We are currently using trainers who are proficient in the vernacular language as well. We provide training content in all the local languages, and we'll be ready and more than ready to take it up with you.
Yes, thank you, sir. Actually, what is happening in the steel industry, you got a quality assurance department which works seamlessly from the raw material till the end, till the marketing part. Even the customer's feedback has been taken. You will be taken by the people. So what I would like to tell you is that new people, those who are coming from the colleges or after doing diploma and degree, so they are, if they are skilled beforehand, what will happen? Each point, because everybody is looking after Six Sigma, you're going for Six Sigma. So if they are trained in before coming to the steel industry, it will be beneficial for all steel industry people, because they understand the quality part of it. Once you know the quality, you get a better product which is needed by the normal industry. So this is one thing. And can you develop a decarbonization skill development? It's like the audit. Not only each part, it's also audit part also. So I would like to, request you to go for a total a course-like thing, so that all the steel industry people, as well as those who are coming to the steel industry, they will know about this total project, and they will come to the industry and they can serve in a better way.
Certainly, sir.
Well,
there are two things. One is that Mr. Bhattacharya has mentioned about the cohort between steel sector, skill council and mining. And it was decided that one common job role that will be prepared, which will be applicable for steel manufacturing as well as for the mining sector. And we picked up this quality assurance, because quality assurance is applicable for both manufacturing as well as in the mining sector. And your help was sought, and I think this will be developed as a separate QP. So far as decarbonization is concerned, we have already developed, as Mr. Bhattacharya mentioned, 5 job roles. One is the operator for injection of green hydrogen in blast furnace, process manager for injection of green hydrogen in DRI, in the vertical shaft furnace, process operator, process manager for injection of green hydrogen in blast furnace, and process manager for water treatment, because green hydrogen is a hazardous material and a lot of water treatment. So these 5 job roles have been approved by NCBET. The problem is that we require steel industry to come forward for a awareness campaign, because decarbonization is a technology which is just being introduced in the steel plant. So we wanted to introduce as a awareness campaign with this job. So I think this will be the part has been done, the development part, content, curricula has been developed. Only thing is that starting initiation of the program as a awareness campaign and then take it up as a regular skilling program.
Okay, that's fine. I think you have something to say.
Good afternoon, Mr. Bhattacharjee. Just a small little observation and a question also. 67, you said job roles have already been identified, and there's a demand of almost about 20 lakh. That's 2 million people up to 2030, if I read you right. Currently, with our 300 odd ITIs in the state, West Bengal can only pump out a maximum of 35,000 per year, and not necessarily all of them will go into this trade. If we assume just 10%, the numbers itself, I be pardoned for countering what my friend was saying, rather than looking at the qualitative aspect, have you even looked at these numbers? Because the quantitative demand is going to outstrip even the supply that's going to come from just a state as huge as ours. You will require at least 20 other states to contribute similar numbers to satiate this demand. Anything that the Skill Council has done to that effect? Because you'll have to galvanize this force to meet up this demand only till 2030, irrespective of whether they go into a qualitative aspect of green steel or any other thing. Even a normal work, if they do, where will you get these numbers from?
Thanks. I must say that the graduates from ITIs and diploma colleges are inducted to be in future taking up supervisory roles. In addition to that, you have a huge cohort of workers who are class 10 classes graduates or not even class 10 graduates. So they are hired by contractors in job roles which are numerous: scaffolder, fitter, welder, and we conduct courses for them as well. So these courses could range from anything like about 5 days for a guy who is already experienced in welding or fitting, or it could be for a novice for even up to 3 months, about 500 hours, 450 hours of training. So there's a huge set of workers who come from this background who are not ITI graduates. There is a huge network of contractors who are constantly sourcing them from their native locations and getting them certified. In fact, today the practice is that even uncertified people are being taken in. However, the large integrated steel plants, whether they are Steel Authority or Tata's, Jindal's, they ensure that each and every contract worker has to pass a basic test at the entrance to the plant. And in order to pass the test, they must go through some sort of a training. We are one of those training providers. There are many other parties who also conduct trainings at the grassroots level. I agree with you, it's a humongous task, but then we are a large nation with a whole lot of agencies engaged in this. And you know, where there is a demand, there is also a supply which is created for it.
Just one added question to that. Something similar to what he was saying, and I come from a small place called Pune. There we had something run as sandwich courses. During our engineering itself, we were pumped into the industries. I went to Telco, Tata Motors now, and that is where we were, taught to work and at the same time understand what is being, is the demand. Unfortunately, I don't see that happening here. Despite of such a large number of MSMEs out here, such a large number of contractors, as you already said. So if the demand can be like, if the supply can be jigged to the demand that is going to come in about 2 years of time, can't these courses be brought forward and taught to the courses which are, to the students who are already in the pipeline? Has there been any kind of thought process to this effect in the National Skill Council?
This is a very good question. In fact, this troubled me also. 20 lakhs, what he has shown, it is the total skill gap. So what you are saying, ITI graduates, ITI, once they complete the courses, they need about a very small, duration, maybe 4 or 5 days skill training as per the contents curriculum, because they have already done the theory. Only the practical aspect, the hands-on training, that they need to do after following this. So your question is answered that way. That 20 lakhs is the, including, say, he has said school dropouts. That also they require skill training. And what ITI graduates, they have their theoretical training about 1900 hours, 1.5 years, 1900 hours courses. But hands-on training they require. So that is the one aspect. The second aspect you have asked for, what was your
engineering graduates.
Engineering graduates for technology. Engineering graduates also, the BTech, suppose BTech engineers, when they are recruited by a steel plant, a lot of them have come back saying that they also require about 1.5 years training, hands-on training at the shop floor, which they didn't have in their curricula. In the engineering curricula, in the engineering colleges, hands-on training is not given. It is all theoretical. Yes. So what are the courses and contents curriculum which has been approved by NCVET, what the Skill Council is doing, that is 80% is hands-on training, 20% is theory. Because our objective is that ITI fellows which are already where they do not need any theory. They need only that 20% of the hands-on. So this is a good mixture what the government has thought of NCVET courses. It is called National Skill Quality Framework, NSQF. And when the certificate what Mr. Bhattacharya is giving, there the NSQF level is mentioned. It is level 3, level 4, level 5. That means he is already skilled. Skilling means he is a supervisor. He doesn't need any supervision. If he needs supervision, it is level 3. Like welder, it starts from level 3. But when he becomes a welding supervisor, he doesn't require, so he is level 5. So that is how, the courses, actually, there has to be a mixture of hands-on training and theoretical training. This is what is missing all through in our courses. Exactly.
This is an area where we are also required to interact with the ITIs and engineering colleges. It has frankly been at a very, very nascent stage. We need to convince individual colleges or universities to take up our courses as a credit course in the final semester of the colleges. Now, let us say that compared to the steel industry, 1 or 2 of our sister councils, like the Automotive Skill Council, have been more progressive and proactive on this respect, and they have tied up with certain universities. Electronics Council is another one. So we hope in due course we will be able to up our game and also do it. It is not yet mandated by the NITs and the IITs, but the private engineering colleges are slowly taking it up with us.
Okay, I think a lot of time has gone in this. I mean, you can have further discussion during the tea time. Okay, we'll move to our next session, next paper. It will be presented by Madam Riti Chatterjee. The topic is from connectivity to cognition, rethinking, rewriting, and renewing. Yeah. Madam Chatterjee, I'll just introduce. Yeah, she's currently an entrepreneur, has a 31 years career in IT industry, started in NTPC, MS-DOS2, TCS, Cognizant, IBM, RCOM, etc. She has delivered large multi-million-dollar complex system integration projects with 500% productivity. At 53, she decided to step down out of corporate to build up a startup company that will grow our future generation to work from the first principle and imagine to innovate. Madam Chatterjee, please.
I will wait for him to have some answers for your questions. Probably that's what my company tries to do, although we are very small. I think, am I audible? Yeah, okay. So basically, plumule research, the word plumule means the new shoot, right? From the seed, the new shoot that grows, right? So we treat all the students as plumules, and to be able to create research mindsets means capability to think on the feet and imagine and innovate. So we have a lot of engineering students working for our projects, and they are grown with the capability to understand what can happen in future. You know, that's very important because we do not teach this, and they will not learn this until they work in a project, in an industrial project. So with that, I will get started. So today, my topic is around not a very common topic, you know, it's on the connectivity in the plants, right? And so we started working on before doing industrial projects, we used to run experiential learning sessions, you know, basically training a group of students, not training also, we used to just give a problem and ask them to solve, right, industrial problems. But then we ourselves, when we joined doing the industrial projects, we started working on IoT and AI-based projects, so Industry 4.0. And the first project was on AQI, and we worked for Indian Railways. You would have seen in the Sialda Railway, you would have seen this big TV portal showing the AQI, right? The entire device was built by Poulomish is there, okay, by the team. Right, and it was assembled, and connectivity was never a problem. We just used the Wi-Fi, end-to-end QTT. It's all seamless, right? The next project, this is at Durgapur Steel Plant, where we built our own thermal imaging solution with a very small camera on the sinter plant, and we designed the entire box. So we actually learned also the process of how to deliver a device building right from scratch, and that will work, and has been working for the last 1.5 years in the sinter plant, in the place like sinter plant, where it is full of dust. This is an electronic equipment working seamlessly, no maintenance required. Okay? So, but then again, how to transmit this imaging data, thermal imaging data, right? You can see the, this one, right? It's continuously in real time advertising across the plant LAN, how to do that, right? So we used fiber optic network, Ethernet LAN, fiber optic network. Well, very common, everybody uses that. This is the first time we went into doing, you know, wireless kind of communications using M2M SIM in a plant environment. This is for Matix fertilizers, where we were detecting trains as they were coming. We were using AI to detect the trains and then send the message over M2M. There also it went very well, no problem. We went well. This is one where we faced some problem with communication, but we could also do it. This is a SOS band made for, you know, women who are in distress, who need help, some domestic violence and all, they need help, so they can just press a button and the SMS will go to a central supervisory location, right? It's police station or wherever they want to get the help from. So the challenge here was that if you see this PCB, it is a flexible PCB, the challenge here was that in these thin copper wires, how to send a 2 ampere current. So we replaced this with, you know, simple wires, and it worked fine. Okay, that's okay. Okay. Yeah, okay, fine. So far so good. This also went good. M2M SIMs in the field. This is in Jehanabad, close to, you know, Patna. and real-time detection, and also, analysis of the greenhouse gases and the soil pH, soil conductivity, all these things. So this also went good. We did not face any problem. So we became very, very complacent. So the next 2 case studies is where we got stuck. Okay? So we thought, yes, M2M SIM, everywhere it's going to work, right? Iron plants, it's going to work. We should not have any problem. But then when we went here, so we had our industrial IoT gateways, and this is, in steel plants we have this carbon monoxide pipelines, right? And we blank out the pipelines with water. So there are tanks which store this water. So we were asked to monitor the level of these tanks. There were 11 such tanks. Monitor the level of the tanks using ultrasonic sensors. Now when we tried to send data from here, that is where we got stuck. And this is the first time we understood that wireless communication is so, so difficult in an iron and steel plant. So let's look at this iron and steel plant. This is what it is, right? There are so many structures, steel structures and steel pipelines, everything, kind of not allowing us to communicate. And we were setting it up in coke ovens and sinter plants and whatnot. And we found that even though we were trying to send again and again, the data was not reaching the server. So even continuously there was a package drop and we were not able to send the data. So what was the reason? This is what is exactly the cause. So our data was finding, the RF, radio frequency in which we were sending the data, was finding different paths to travel and then finally cancel each other. So the many times we retried, the more it canceled and the more it did not reach the server. So this is what is multipath. You will see that, the original signal, if you see original signal, right, should have gone this way and straight to the server, but instead there were several reflections, several paths, and finally they just cancel each other. So this is where, it was getting stuck. This is the picture. If I just try to show what happens to this radio frequency wave, so there is multiple reflections, different places it is absorbed, refractions, it's just, kind of bending, and scattering, so this whole thing is a mess. And to communicate using Wi-Fi, using 4G or 5G or whatever, is so very difficult. And so basically all these structures were actually not only absorbing, they were preventing, they were blocking the whole thing. And if you really look at it, now these are called, this type of reflections are called specular reflections. If you look at, this, like you have an exact reflection, it's almost like this, right? So it's easier to think in terms of light. So that's why I've used this imagery. So multiple signal paths, and then there is interference. It can be constructive, it can be destructive. Finally, the signal gets weakened and delayed also, weakened also, and it doesn't trace. So, when we are working in these areas, right, in the cast houses or in the conveyor tunnel galleries or in the gas mains and pipelines, this is a very, very common event. Adding to that is the aerosols and the dust. So what does the dust do? Dust absorbs all the RF waves. And what happens? The RF waves will get absorbed, they will heat up, there's a loss of the RF energy into the heat energy or thermal energy, but it finally doesn't reach the destination, that is the server where we want to send. So this was happening. But then what we did is that the immediate thing, so now we had this project was not very high valued project, and the thing is that what we had done is the easiest process of doing a 4G communication, right? And so we had used VI M2M SIMs. They're comparatively lower in terms of rent out, and we found that it was not working. Then we learned that there was a Airtel tower within. So we try to work with normal Airtel SIMs. Now, M2M SIMs are not allowed in all the towers. So normal SIMs are better. And we found that we could significantly improve the performance. But still, if we say, so it was significantly improved, but still if we say, there are still drops in the packets that are happening. So if we are going for digitalization of big plants, and if you are allowing instantaneous automation, especially in iron and steel or ferroalloys, whatever, right, we cannot avoid using wireless communication. And to make wireless communication work, it's simply a different paradigm of thinking. And I know we don't talk much about communication, but if communication is not proper, then things will not happen in time, decisions will not be taken in time. So it's as important as that. And that's why, we have started working on a few alternatives to whatever is existing in the public domain today. So being able to use eSIMs, now working on devices, we are making our own eSIM devices where you can actually control the deployment, you can control the power with which we can communicate, and we can add multiple providers, network providers. And this is another area where we are working, that is OFDM, where we are looking at dividing the entire range. Instead of, let's imagine like instead of a truck full of load going from one place to another, we are sending by mini trucks with lesser loads in parallel. And that's more successful, right? So this is called OFDM, orthogonal frequency division multiplexing. Now it's also called orthogonal, means the first set you send in one direction, the next set you send in perpendicular direction, so that they have minimal interference. We have a little bit of overlap in the frequency, but there is no interference in terms of amplitude, right? So if you look at the signal going over the wave, over the carrier waves, there is no interference between the values. So we can run it this free of multipath and free of EMI. So this is where we are actually working on currently. So this is another thing that we are working on, but to make this happen, robotics happen in the iron and steel industry, we should improve the communication backbone, and that's absolutely very, very, very crucial to be able to take decisions in time, right? So that's important. And so finally, can we continue with Ethernet with the level of digitalization that we have today in all the industries? Probably not. We cannot go and create cable everywhere. It's also against, decarbonization. And the connectivity for automation is becoming very, very pervasive now. It's becoming very pervasive. You feel you do, you feel you do. Like today we are working on a project called, project in which we have to predict silicon in the hot metal. And it's so fast varying. So we feel we do, we know every small reactions that are happening and we be able to do it, right? And that requires very perfect communication in time. So we have to focus a lot on the communication technologies that we are using today to be able to go to that level. And the DOT is doing something towards it. DOT is experimenting on 5G, private networks, CNPN, non-public networks, right? Special frequency bands are going to get allocated to the 5G providers to be able to, and we can use those bands in which to do this communication. So then it becomes secure, it becomes reliable with a deterministic service, right? And of course, this is a way to move the data in the leanest possible way. So when we kind of got stuck with our tank project, 11 tanks, right? And I estimated the cost of the Ethernet LAN. It was double the cost of my whole setup. I could not afford it, right? So I have to look for other solutions. In fact, these are the necessities that are forcing us to work. So I would like to end, to make. So I remember this quote every time. I heard this in 2005 when Kalam sir had come to Kolkata to give his presentation, and he urged everyone to integrate, to innovate. I think there's a lot of integration that needs to be done in terms of having standards and global vocabularies in which all the steel plants and the ferroalloys can work together. We look at standardizing how we source data, how we channel data, in which frequencies we channel data, and how we sync data. Then it will become a very good interoperable supply chain. Thank you.
Thank you, Madam Chatterjee, for an excellent presentation. You may take your seat. We may have a couple of questions from the audience, if you have any. Okay, if there is no questions, then I'll just sum up just by 3 words. I mean, in this session, we had 3 presentations on 3 varied topics, you know. First was on DRI smelting and arc furnace. Second was a completely different thing, that is skilling in the metal industries, especially. And third is the data capturing and data transmission and data filtration and all. So it's an excellent presentation. I thank all the presenters to present excellently in this session. Thank you very much. Now I hand over to the organizer for the next announcement.
Yeah, thank you, Dr. Ray, and thank you all 3 presenters, Mr. Bhattacharya, Riti Chatterjee, and Juha, for the excellent presentation, and thank you, audience, for the excellent questions you asked. Thank you very much once again, Dr. Ray, and all 3 of you. Can you please, Dr. Rai, to help to give them a small token of appreciation from our end?